Okay, we're going to be talking about the stoichiometry of chemical formulas. What I was trying to get across to you in class was that 1 mole of sodium sulfate, Na2SO4, contains 2 moles of sodium ions. And this seemed to be relatively tricky. So, what I really am talking about is very similar to what happens in a car. How many tires does a car have? 1, 2, 3, 4 tires. We can rewrite that out as a conversion factor. So 1 car contains 4 tires, or we can also say that there are 4 tires per car. There's the conversion factor for you. Just like density, whenever you have that per, miles per hour, you can say that 1 car equals 4 tires. So, how many tires does 5 cars have? Well, we've got 4 in the first. We've got another car over here that has another 4. 4, 4, 4. So we can count them all up. We can say that 5 cars has 20 tires. Or we can use dimensional analysis. We're going to start off with 5 cars on the outside. We know from our conversion factor that every 1 car contains 4 tires. Double check, make sure all the math works. Cars cancels with cars. We're left with a unit of tires, which is what we're looking for anyway. And we get an answer of 20 tires. So that's what's going on with tires. 1 car contains 4 tires. We can do the dimensional analysis in order to figure out how many tires 5 cars have. Well, the exact same thing happens when you're talking about chemical formulas. So, let me see if I can... So, now we've gone past cars, we're going to start talking about chemical formulas. 1 mole of sodium sulfate contains 2 moles of sodium ions. We're going to try to explain that. So, here is what sodium sulfate really looks like. So we have the sulfate anion, it's a polyatomic anion. We have sulfur in the middle and it's bonded to the 4 oxygens. 2 of those oxygens have negative charges. That's why sulfate has a -2 charge. In order to balance out that -2 charge, we have 2 sodium counter ions. So there's 1 sodium counter ion, it balances out 1 of the negative charges. We have another sodium counter ion over here that balances that out. So for every 1 unit of sodium sulfate, you get 2 sodium ions. That happens no matter how many. That ratio of 2 to 1 never changes. So we can say that 1 sodium sulfate, we're talking molecular now, microscopic, contains 2 sodium ions. So we can use this conversion factor. What happens if we were to have 5 sodium sulfate molecules, 5 sodium sulfate units? Well, that means that we have 1, 2, 3, 4, and 5. We have 5 sodium sulfate units. We get 2 from each one of them. 2 plus 2 plus 2 plus 2 plus 2. 10 sodium ions in 5 sodium sulfate units. The same thing happens if we were to go all the way up to a mole. Remember that mole is just a number. It means instead of having just 1 sodium sulfate unit, we have 6.02 times 10 to the 23rd sodium sulfate units. But that ratio of 2 to 1, 2 sodium ions for every 1 sodium sulfate unit doesn't change. So, since the ratio doesn't change between sodium ions and sodium sulfate units, even when we go up to the macroscopic level in terms of the mole, we can still write this as a conversion factor. 1 mole of sodium sulfate contains or is equal to 2 moles of sodium ions. There's still 2 moles of sodium ions per 1 mole of sodium sulfate. So let's say that I ask the question, how many moles of sodium ion are there in 4.56 moles of sodium sulfate? Straight dimensional analysis. Start with what the question is asking you about. Keep your units. Units are moles. Keep your label. Label is sodium sulfate. So 4.56 moles of sodium sulfate. And for every 1 mole of sodium sulfate, it contains 2 moles of sodium ions. So 4.56 times 2, 9.12 moles of sodium ions. And this is all based on the chemical formula. That chemical formula subscript of 2 is where I'm getting this ratio of 1 to 2. If I was instead talking about sulfurs, for example, 1 mole of sodium sulfate contains or is equal to or has 1 mole of sulfur atoms, because the chemical formula, there's no subscript there, so it's implied that there's a subscript of 1. So 1 mole of the whole thing contains 1 mole of sulfur atoms. There's 1 mole of sulfur atoms per mole of total sodium sulfates. And let's do one more for the oxygen. 1 mole of sodium sulfate contains or is equal to 4 moles of oxygen atoms. Again, based purely on the chemical formula. That's what that subscript is really telling you. There's 4 oxygen atoms per unit of sodium sulfate, which means there's 4 moles of oxygen atoms per mole of sodium sulfate. I hope that clears things up. I'll be posting more videos about stoichiometry shortly.